Welcome to Unit 5, Linear Relations. This is Lesson 5.1. We're going to write equations to describe patterns. So this whole unit about graphing is all about patterns, and we're going to use the patterns to create an equation. So if we take a look at our pattern here, we're going to be comparing people for the number of people and T for the number of tables. So if we take a look, on the very first table, we've got 2 people, okay? On the very first table. So, if I say that this is my number of tables, okay, number of tables is the middle number, okay, number of tables. The 2 on the very front, what do you think the 2 is? What does it represent? Okay, which people? The ones with the happy faces or the circles? The happy face people, you betcha. So these are the base people. Okay, those are our happy faces. So we've got 2 people always, and for every 1 table we add 2 people. So what do we notice if we add 1 table right here? We're adding how many people? 2 people. So if I've got 2 tables next time, I'm adding 2 more people. Now let's take a look at the next one. I have 3 tables, and what are you noticing here? Well, our base people, those are our happy face people. How many people are on the top row and bottom row each? 3. 3 across the top, 3 across the bottom. Same thing here. What if I have 4 tables? If I have 4 tables, I've got our 2 base people on the very end, the mom and the dad that got to sit on the end with the grandma and grandpa. And then we've got 4 people. That means 4 chairs going left to right, 4 chairs going left to right. Okay? So 4 tables means 4 people on either side. Okay, that's what it's talking about. So now we can make an estimate and we can guess on where things are going to go. So what we're going to do on the next page is we're going to create, if we have this equation. So they're giving us an equation that represents the tables and the people. So the equation is the number of people is equal to 2 times the number of tables plus the 2 people that have to sit on either end. So this plus 2 is our base 2 people. So if I want to know the total number of people sitting at those tables, I'm going to substitute the number in. So this one is a T number for tables, so I'm going to find out my P number. I'm going to write 2 times the T number plus 2. So my table number they give me is a 6. So you're going to write your equation, and you're going to substitute the 6 where the T is for the tables. So we're going to have 2 times 6, so 2 times the table people. So it's going to give us 12. So with 6 tables, so if I were to just draw my diagram here, 1, 2, 3, 4, 5, 6. My 6 tables, I'm going to have 6 people going across and 6 people going on the other side. That's what this represents. Okay? Then this plus 2 on the end, this plus 2 represents the 2 people that are on the either end. Okay, that's what it actually represents. So if I'm going to do the bad math, and I do the math, I'm going to multiply 2 times 6 first. How big is 2 times 6? 12. Add 2 more. 14. Good. So if there's going to be 6 tables, you're going to have 14 people. Now we're going to do the exact same thing for 10 tables. So we are going to erase the tables I drew, and we are going to write the equation. 2 times the table number plus 2 more people. Now, why do you think we're multiplying it by 2 every time we have a table number? What does this 2 right here represent? That's right. That's the 2 people they add per table. Absolutely it is. So we're going to have 20 people here, plus 2 more is 22 people that can sit down at 10 tables. Then we're going to do the exact same thing for 25 tables. So for 25 tables, I'm going to have 2 times my 25 plus the 2 extra people on the end. So that gives me 50 people plus 2 more. It's going to give me 52 people can sit at 25 tables. So what strategy do we use? Starts with the letter S. Substitution. So we substituted the number where the variable was in the equation. So where the T number was, I put the table number. Okay, that's what we did. That's why we've got brackets in these places, because that's where that T number was. So whenever I had a T number, I put it in brackets beside who we multiplied. Now the next one is a little bit different, because this one's asking to solve for tables, and they're going to tell us how many people came. So I want to know how many tables I need to seat so many people. So if we've got 18 people, this is where we work backwards. So we're going to put 18 now where the P number is. So we're going to have 2 times tables plus 2 people equals 18 total people. So this is where we're substituting the number in, and this was a P for people. That's our P for people. That's what we're substituting in. Now we're back to a normal linear equation that we dealt with last unit. So now we need to make a 0 pair. We need to solve for the letter T. If I'm going to solve for the letter T, that means he's got to be isolated by himself on the left. Well, that means everybody on the right has to go to the right-hand side. Okay, everybody on the left that doesn't have a variable. So my positive 2 doesn't have a variable, so he's going to make a 0 pair. How do I make a 0 pair with a positive 2? Inverse operation, I make it a negative 2. Good job. So now 0 pair, I'm going to make a negative 2 on the other side to keep it equal. So that made the positive 2 disappear. And now I'm left with 2 tables equals 16 people. So how many tables am I going to need? 2 times how many tables gives me 16? It is 8. Now, if I were to do the math, what math operation would I use? Right now I'm timesing because they're sitting squished together. So the opposite is?
Divide.
Dividing, good. So I'm going to divide by 2, divide by 2. So I'm going to get T is equal to 8. Okay? So I need 8 tables if 18 people come. Now we're going to do the exact same thing, but now we're going to change our P number. We're going to change it from an 18 to a 32. So we're going to rewrite the equation. 2 times tables plus 2 people equals now a total of 32. 32 where the P was. And now we're back to solving for T. So we're going to subtract 2 to make a 0 pair. That's going to give us 2 tables equals 30. 2 times tables. So we did the longhand math. And on the last one, my last step was dividing. Is my last step going to be dividing here or multiplying? What do you think?
Divide.
It is divide. Because they're sitting side by side multiplying. So we're going to do the opposite. We're going to divide them. So we're going to divide by 2, divide by 2. That tells me we need 15 tables. So for 32 people, we need 15 tables. Okay? I'll let you finish writing that down. Push pause now and play when you're ready. All right, welcome back. We are now going to talk about what if we've got a table of values. Because often we're not given the equation, we have to create an equation. So we're going to create an equation from a table of values. Here are the steps, steps 1 to 5. I'm going to let you read those on your own. We're going to do it together as an example. So we're going to take a list here. We're going to take a look at our first example. We've got a landscaper who's using wooden boards to design plots for his herb garden. So we're noticing, if we take a look, they've already started our table of values for us. So the number of plots they can make, if they make 0 plots, how many boards do they need for 0 plots? Well, they got to start with something. They got to start with 1 board. If you only have 1 board or 2 boards or 3 boards, you're not going to make a plot, right?
If there's no plots, then you don't need anything.
Well, we're trying to make
Logic.
square plots, logic, yeah.
If we don't have a plot, then we don't have anything there.
Yeah. Good job. Okay, so if we take a look at 1 plot, I want us to count the number of boards. If I look, I've got 1, 2, 3, 4 boards. It takes me 4 boards to make 1 plot. Now, I'm going to outline my first 4 boards. Here's my first 4 boards. And what would they need to add to those 4 boards to make another square plot beside it?
3.
All they're adding, let's watch, is 1, 2, 3 other boards. And then they make their second plot. So if we add 3 to 4, how many boards are in plot 2? 7 boards, good. And how many boards do you think I'm going to have in plot 3? I'm going to add 3 more. So what's 7 add 3 more? 10, good. Now, do we even have plot 4 up here? No, we don't have plot 4 up here. They did that on purpose. They're seeing, are we able to draw the 4th plot? Well, let's take a look. Here's my 3rd plot. I've got 3 plots. 3 plots, I'm using 10 boards. How many boards am I going to add to 3 plots to make 4 plots? I need to add 3 boards. So I'm going to add 1, 2, 3. And there's my 4th plot. So I needed 3 more boards, so that's 13 boards to make 4 plots. Now I added 3 more boards. How many does that make? 16. Good job. Okay. What are we noticing the pattern is? So what we want to do is we want to find the pattern on the X list and the Y list. So this is what we do. We try to find the pattern here. What are they adding or subtracting every time? They're adding 1 every time on the left-hand side. What are they adding every time on the right-hand side? 3. So they're adding 3 here, and we're adding 1 there. Here's our rule, and it was written on the previous page. You take the pattern from the second list, the list on the right, and you divide it by the pattern on the left. So what's 3 divided by 1? 3. So my ratio goes up by 3. So since they're going up by 3, we are going to multiply that number. He's going to sit in front of the variable used for the X list. Now, how do we know who's the X list and who's the Y list? Well, when we're given tables of values, the very first vertical one, okay, that one there is considered the X list. So we call this list 1 because it's written first on the left. So list 1 is always the X list. The second one that's white is list 2, and it's always the Y list. Okay, always, always. So we can have a vertical table of values, which is what this one's called. We could also have a horizontal table of values. It could be this way. P for plots, B for boards, and I could have 0, 1, 2, 3, 4, 5, 1, 4, 7, 10, 13, 16. So they could write it horizontally as well. If it's horizontal, it still goes alphabetically. So what that means is the top one is list 1, which is X, and the bottom one is list 2, which is Y. Okay? Because in the alphabet, X comes before Y, and numerically, 1 comes before 2. So that means that list 1 is always X, list 2 is always Y. That'll never change. Okay? So if you don't like using the words, or sorry, the letters they've used, the variables they've used, then just change it back to X and Y. That's totally fine. But you can also remember, why do you think they're using P and B?
Plots and boards.
Plots and boards. They're using it for problem solving. They want us to make sense of what's going on. So instead of generically saying, oh, well, plots will be X, they're saying plots is P, so that P makes sense for plots. We're trying to logically make sense of the information. So that's where the info comes from. Now, the rule says, we take our pattern from the right divided by the left. That number we get is going to sit in front of the variable X. Well, who's our variable X?
Plots.
It's P for plots. So that means our equation is going to start like this. Y equals 3 times plots. Okay? Now, we say plus or minus something. Plus or minus something equals the Y. Now, this is how we start every equation. We need to find out, what do we put right here? This is our step right now that we're looking for. Is we want to find out, how do we know how many numbers to add or subtract here to create the pattern? Well, so far we know we're going up by 3, but if I were to use one of these digits as test points, that's what's going to tell us what's going on. So, we're going to talk about a test point, and I'm going to write that over here. So, and again, they were written in the rules for you. So, we're going to check a test point. Now, your test point is any point from your table of values. What that means is you want the X number and Y number. So I could take 0 and 1. They have to be together. Which one matches 0? The 1 does. Okay? By matching, I mean they're a coordinate pair. They're a location on a map. So I could use 0 and 1 together. They have to be used across. Or I could use 2 and 7 together. I could use 5 and 16. Whichever numbers I want. But I have to use the same ones. So I'm just going to use 0 and 1 to start with. So if I'm using 0, 1, that's a test point. That means 0 is my X and 1 is my Y. Okay? So I have a 0 for an X number, a 1 for a Y number. And what we do is we put those numbers in here, and then we see what we have to add or subtract to make the left side of the equation equal to the right side. So we want the left side to equal the right side of an equation. That's what we're hoping to do. When it does equal, then we know we've found our pattern for the equation. So we're going to check our test point now. So I'm going to say 3 times the X number plus or subtract something is equal to the Y number. Okay, and this is the X number. So we're plugging in the X and the Y number that we chose for a test point. I'm plugging in my 0 for X, and I'm plugging in my 1 for Y. Now I'm doing BEDMAS. So now I'm going to solve this part right here. 3 times 0 is 0. Well, 0 plus or subtract something has to equal 1. What do I have to add or subtract to 0 to get a 1? Do I add or subtract it? You add it. So then I know this is a 1, and I can cross off the subtract sign. I don't need that subtract sign anymore. I just need the positive 1. So now I go up to my equation, and I say, okay, we figured out we needed only a plus 1, but we have to check one more test point to make sure it works. So you always have to check a second test point. So now I'm going to check my second test point. I'm going to use 2 and 7 just because I have it circled. So now I'm going to put a 2 where the X is. So 3 times my X, we're going to say plus 1 equals my Y. Okay, and we're checking the test point 2 and 7. So I want a 2 here and a 7 for Y. And I need to see if the left side equals the right side. So I'm going to do BEDMAS. 3 times 2 is 6 plus 1. Does it equal 7? Yes. The left side does equal the right side. So that means we created the proper equation. We know now that it's 3P plus 1 is equal to the Y, or we could say B for board. They're using B for boards instead of Y, so I'll use B for boards. Yes?
Where came this 3 from?
This 3 right here?
Yeah.
That came from our pattern here. When we took the pattern from the right-hand side, okay, we took this guy's pattern, going up by 3s, right here, and we have to divide it by the pattern on the left, 1.
Oh.
So that's where we get 3 over 1, which is 3. Okay? Now, let's say, for example, 3 was there, but maybe this was a 2. Let's just pretend it was a 2 for a moment. Then it means that this would be a fraction. This would be 3 over 2. Okay? And that's okay. All right? We will get more questions coming that will make more sense. More examples, more practice. All right, let's take a look at the second example. Second example is about an airplane. He's up in the air, and he's cruising at a height of 10,000 meters. And he's starting to descend to come down to land. So what we've got is this. We've got our plane, and there's our plane. He's coming down to land on the ground. Okay, that's what's going on. Yeah, it looks like a blimp. That's my plane. All right. So we have to find the pattern for our x and our y. So this is our x, this is our y. So what is the pattern doing on the right-hand side? What's going on with the pattern on the right-hand side? What are they doing to all those numbers? That's right. We're subtracting 300 every time. So subtract 300, subtract 300 every time. And what is the pattern on the right-hand side? Or sorry, the left-hand side. What's this pattern? They're going up by 1s. So the rule is you take the pattern of the y and divide it by the pattern of the x. Well, anything divided by 1 just stays the same. So we know our pattern is negative 300. But he's got to sit in front of that letter. They're using T for x, okay, and they're using H for y. So we are going to start our equation. So we're saying negative 300. So negative 300t. Now we say plus or subtract something equals h for height, the y number. So we've started our equation. Now we need to check our test points. Okay? So remember, how did we get that negative 300 in front of our variable? What did we do?
We figured out like what's subtracting.
That's right. We found out the rate of change. This is called the rate of change. Okay? What he's going up and down by, this is called the rate of change. Let's move our plane over. So this is our rate of change. So how fast or slow something's happening. So the rate of change creates the number in front of our variable. Okay, that's called our slope. So the rate of change. So what is our h number? Well, we got to pick a test point. So I'm going to just start with my very first one, 0 and 10,000. So that means I need to put a 0 where the t is and 10,000 where the h is. So I'm just going to write it below. Negative 300. I'm putting 0 where x is. Plus or minus something equals 10,000. Well, what do we know 0 times anything is? 0. So it's always a good number to start with because 0 times anything is 0. So what do you have to add to 0 to get 10,000? 10,000. Okay, so now we know the number that goes in that box. Now are we going to add 10,000 or subtract 10,000? 0 plus or subtract what gives me 10,000? Plus, we're going to add it. So we can cross off our subtract sign. And we know now that 10,000 goes in my box. So my equation is negative 300t for x plus 10,000 gives me the height of my plane. All right. We're going to check one more test point to make sure it works. All right, one more test point. Negative 300 times the number plus 10,000 has to equal the other number. Okay, which test point do you want to use? 2? Okay, 2 and 9,400. We're going to use this one right here. So 2 and 9,400. Let's see if the left side equals the right side. So if I do bed mass, I need to multiply. What's 2 times negative 300? Negative 600. So I've got negative 600 plus 10,000. How big is that? 9,400. So the left side does equal the right side. So that means we have the proper equation. Okay? Now we can answer the following 2 questions. So, letter C says, what is the height, how high is the plane, after 15 minutes? Okay, well we've got to put a 15. Well, is the 15 a time number, or is it a height number? It's a time number because it said minutes. So we're going to put it where that 2 is. So negative 300 times 15 plus 10,000. That's going to tell how high it was after 15 minutes. Yes, Lance?
Can we just go find out what 5 minutes to without equal and then find out by 3?
It's a constant rate of change. It might work. It might work. Let's check this one. So, 15 minutes, we're going to get negative 4,500. Negative 4,500 plus 10,000. So how high is it in the air after 15 minutes? Add the 2 numbers, what do you get? 5,500. Now this is a Y number, this is height, so we have to put M for meters. Okay, use your units, don't forget. Now, let's take a look. The next question says, how long, so it's looking for a time, after it starts to go down, descending, does it take the plane to land? Well, let's just look over here. Here's our diagram of our plane. They want to know how long it takes them to land. So what they're actually looking for is that number. So on the X line, or on the ground, is the plane going up or down at all on the ground? No. So on the ground, we call the ground level 0 for height. So if the ground level is a 0 for height, we can easily find out how long it takes. We put 0 for height. So we're going to go right down here, and we're going to create our equation, only now we know that the H number is 0. So we've got negative 300 times plus 10,000 equals 0 for height. And now we're going to solve for how long it takes for it to land. Because we're solving for t time. So again, this is a basic equation. We take the guy without the variable to the right-hand side. So we make a 0 pair by subtracting 10,000. So we're going to subtract 10,000 to both sides. And now we're going to get negative 300 t equals negative 10,000. And our last step is to always divide by what's sitting in front of the variable. So divide by negative 300. Divide by negative 300. So now, we like that both of these numbers were negative, because when you take a negative divided by a negative, you're going to get a positive answer. So we like the negative divided by negative situation. And that's going to give us 33.3 repeated. And remember, this is in minutes. So in order to land on the ground, it's going to take 33 1/3 minutes. Okay, that's how long it takes for the plane to hit the ground. 33 1/3 minutes. Okay. Let's take a look at our last example here. We're going to talk about a cab ride.
Cab ride.
Yeah. Our final example is a cab ride. So the cost of a cab ride has a fixed cost plus numbers per kilometer. So whenever we want to find an equation, we always start with the fixed cost. So our fixed cost is $3.60 plus $1.50 per kilometer. Now, if you remember from the previous unit, wherever we had the word per or every, those digits were the ones that got variable. So that's why I put the variable K for kilometers with the $1.50. So that's the expression. What is the difference between an expression and an equation? That's right. The equation has an equal sign. So now all I've got to do is I'm going to write my expression, and I need to put an equal sign. And that's going to equal to total cost. Okay, so it's total cost for your distance traveled. Okay, and I got to put my K. You can put D for distance if you wanted. So K, or I used a D. It doesn't matter if you want to use D distance or K kilometers. I put K or D on top. Doesn't matter, whichever one you want. Now, the next one says, what is the fare for an 11-kilometer trip? So you want to find the money out. Well, remember, total cost, that's your Y number. Because whenever we have an equation, we always want it to be Y equals an X number. Okay, plus or subtract something. So that means whatever letter that we're equaling it to, that's our Y value. So that means that this guy is our Y value. And the D, or the K, is our X value. So we have to know who the X and the Y are. Now we do substitution again. So we're going to write our equation, $3.60 plus $1.50 times the amount of kilometers. And this one tells us we will go for 11 kilometers. We need to do bed mass now and find out total cost. So, bed mass total cost. First thing we're going to do is multiply. So $1.50 times 11. $16.50. Yep, $16.50.
So that means
Yeah, 0.5 is 50 cents.
you have to add.
Okay, so now you're going to take $3.60 and add it to $16.50. And that's going to give you a total cost of how much to go to 11 kilometers.
$28.
Good. So remember, yes, you would have got an answer of 20.1, but we're talking money. So you must put the 0 at the end because that's dollars and cents. So it's going to cost $20.10 in order to go 11 kilometers. Letter D. How is letter D different from letter C? Okay, they're going to give us the money value instead. So what are we doing? That's exactly right. So in letter C, we were given the X value and asked to find a Y value. In letter D, we're given a Y value and we're asked to find an X value. This is where we solve for X. So we've got $3.60 plus $1.50 D or K, whatever you want, equals $32. So our first step is to take the number without the variable all the way to the right. So that's $3.60. So we're going to minus $3.60 from both sides. So we're going to minus $3.60 from both sides. So that's going to give us $1.50 D or K, whichever you like, is equal to $28.40. And now your final step is to divide by $1.50. Because you want that letter D or K, whichever you use, by itself. So now our $1.50 is gone. And it equals 18.93 repeating kilometers. So, do you have enough money to go a full 19 kilometers?
No.
No. You cannot go a full 19 kilometers. You have to do a little bit less than 19 kilometers. So, this concludes lesson 1 of 5.1, linear relations creating equations.